This is one of my solar heaters. We can see that it looks like this my solar station, which turns solar energy into heat for space heating this house in the winter and for heating the water of this pool in the summer. In addition, we might think that it is similar to this type of solar power plants. I remind you that these mirrors focus solar radiation into this receiver, where the radiation is converted into thermal energy at nearly 400 degrees Celsius, which produces steam to generate electricity. My mirror also focuses the solar radiation that forms this spot, and now I temporarily set a white screen here so that the spot can be seen better. More than 100 of these solar power plants have already been built, and for example, this power plant cost about $2 billion. But these power plants use very expensive solar heaters with a total construction cost of several $100s per square meter. At the same time, our solar heaters should be 10 or 15 times cheaper, and therefore they can give us very cheap thermal energy, the cost of which we can calculate very approximately by this formula. Here we see that this formula requires a reduction in the cost of our solar heat to a level of half a cent per kilowatt hour, and it is approximately 10 times cheaper than the cost of heat from natural gas. This cheap heat can be used to generate electricity at this cost 5 cents per kilowatt hour, and this formula was explained in this my recent video. The conversion of our cheap heat into electricity is done by steam turbines and heat storages, which provide the production of solar electricity not only when the sun is shining, but also at night and on non-solar days. So, each of us will come to a similar design of a solar heater if you persistently and phonetically implement the idea of maximum simplicity and a minimum of elements. This simplicity causes our solar heater to become very cheap and provide cheap thermal energy, which can be converted into electricity that is cheaper than electricity from thermal and nuclear power plants. Now I remind you that those expensive solar heaters must constantly turn according to the movement of the sun across the sky, and usually they are placed perpendicular to this east-west line. Unlike them, the solar heaters of my solar station are parallel to this east-west line. That is why their mirrors may not turn during the day, because solar radiation from my motionless mirrors enters this receiver for most of the day, except perhaps in the morning and evening. But a slight adjustment to the receiver location can be helpful, and therefore my new solar heater has this simple and cheap system for changing the position of the receiver. In addition, several times a year we have to change the vertical angle of the mirrors, and now I show how I do it at my solar station. We see that this is a simple and quick operation, although the salaries of workers will slightly increase the operating costs of our solar power plants. In addition, let's pay attention to this shadow from this receiver, and we see that the shadow is located between the upper and lower mirrors. The shadow of the receiver of these expensive solar heaters is also located here, in the middle of the mirrors. At the same time, the shadow in the case of this new solar heater should be located here, below the mirrors. This is the shadow of this receiver, and we can see that the shadow moves when we change the position of the receiver. I plan to make a separate video describing this type of solar heater and its differences from these types with the location of the shadow in the middle of their mirror surface. In addition, I am planning to make another video where I will analyze the perspectives of this type of mirror, which is a sheet of cheap stainless steel of this mark. Perhaps also I will make other videos that will analyze other types of cheap mirrors, for example such a mirror which is a reflective polymer film on a sheet of expanded polystyrene. Another one of my future videos will detail this mirror structure and analyze its possibilities to achieve this total construction cost, $15 per square meter. Another video will describe the possible types of this receiver and the various possibilities to reduce its cost to this level, $12 per meter. Now my receiver has a design that is based on these two steel pipes with ribs, and these pipes are paths for water or thermal oil, which is heated by solar radiation from our mirrors. The receiver should be covered with something like this transparent plastic sheet or transparent film. It is obvious that we can use other types of receivers, and for example, we know that such evacuated tubes are commonly tried. I also plan to make new videos on different types of simple and cheap systems for moving our receiver, and for example, this type was described by this my old video almost a year ago. Similar receiver movement systems must match these construction costs. I want to clarify that this steam jet does not adequately show the real thermal capacity. Before this, the receiver pipes was without water for 10 minutes, and therefore the sun heated the pipes to a high temperature, and then I gave them water through this hose.